as the new number of dummy variables necessary to represent a single feature is equal to the number of categorical categories in the features minus 1, we can remove the dummies created. Let's say embarked S, for example. This will not remove any information because by having embarked C and embarked Q, the algorithm can easily understand the values of the remaining dummy variables, where embarked C, embarked Q are 0, embarked S will be 1, otherwise it will be 0. All right, so this whole explanation right here is just trying to say, after identifying your features, you want to identify which ones are categorical, which ones are continuous. Because the model only, of course, the model only reads numerical values. So we come and see, okay, we have, for the features we're going to consider P class, we're going to consider age, we're going to consider sex. So age is already numerical, so that's fine. So sex is categorical, but it is in string format, so we have to preprocess, we have to encode it into like ones or zeros, and also P class is also encoded into ones or zeros according to. So that whole process we use, there's a library called preprocessing, sklearn preprocessing libraries that helps you do that, and this is the code for doing it. So the process of encoding sex, we're going to use label encoder, and then so you see this is the variable from the data frame, and then they use label encoder, which they just gotten by instantiating the label encoder class, and then they do a fit transform, and then that we shall see how the resulting data will look like. So you can see now sex is no longer male and female, it's now ones and zeros. Okay, and then now they have to also embark. For embarked, it's also a categorical variable. We have to also encode it into ones and zeros. But first, we have to, of course, check for missing values. Before you encode, you have, if there's an if there's a null present, it will wonder how to encode that. So you have to first cater for missing values. There are different various ways of catering for missing values, and in this case, how they catered for missing values is by replacing the missing values with the most popular class, which is S. Okay. All right. So this is how they just got the missing values, and then they replace the missing values with S. That is basically it. And then previously they used label transformer to encode sex as from categorical to be to be numerical ones and zeros, and here they've used get dummies to they get dummies method to encode the embarked variable into ones and zeros. So now it is going to look like this. We are going to have embarked C 0. If it is embarked C, you'll find it's a 1. If it's embarked Q, you'll find it's a 1. And then they will drop embarked S. If you want, you can leave it there, but you can. They say that you can drop it because the model will know that if the rest of this are 0, then embarked S is probably a 1. Okay. So you may wonder why we still have the name variable. In fact, the name does not seem to have any influence. It doesn't matter if a person is called Owen or William. However, this column has the title located after the surname. However, this column has the title located after the surname and the comma, Mr. or Mrs., which is useful. So if we take a look at the table X displayed previously, we shall see there are missing values for the age column. Removing these rows with missing values could involve removing 177 rows, which is quite a lot, and we would have less information to create a model. In some cases, it is acceptable to take the average of the column and replace with the nulls. Nonetheless, in this case, it is possible to estimate the age of the person by their title, which is present in the name value. So this is just telling you that the name column, we maintained it so that we can use it to infer the age of that person in case they have a missing value of age. And there are very many ways to handle missing values, like I told you. So in this case, what they did, they're going to get their title and then infer their age. So therefore, I will first identify the different titles present in the age presented, and then the average of the age for each title. we can provide the averaged age found in each title to the people missing the age according to the values name. So I'm not going to go deep into the code of what they did here, but at the high level, first of all, they took care of missing values. They took care of missing values by first saying, okay, how many are the missing values? They can see that their missing values of age is 177. So how can we replace 177 missing values? So the approach they used is they're going to try and get the different titles of the people, and then they get the average of that title. So what is the average age of the people who are called Miss? What is the average age of the people who are called Mrs.? What is the average age of the people who are called Mr.? And then they replace the missing values with that average age. And all that code is right here. So we're not going to go and delve deep into each line of code because that will take some time. So in the end they plot, let's see, this is a plot of average age against the name, okay? So these are the different titles that they've got. They got captain, they got, I think this is an army title, they got doctor, they got lady, they got major, master, miss, and these are the average ages, okay? So for the ones that are missing values, we shall just get this average age and replace it. So we can also make feature transformation. For example, we could transform the age feature in order to simplify it. We could distinguish the youngsters from the adults, okay? So this is another level. So there are different things you can do to your data before you can train it. So you can see that here they're trying to say, okay, let's not just take the age as the actual numbers, because maybe it will help us if we say, okay, this is an adult. We make it categorical. This is an adult and this is a child, by just saying, okay, we're going to use a threshold of 18. So they're just going to say, so instead, you see now, before when age was just a bunch of like actual numbers right here. Right now, age is either 1 or 0, whether you're an adult or a child, which is much, much simpler. Now we can see that we have we have a quite well clean data set to provide to our classifier algorithm. So you can see, you can compare, as you're going through this data set, you can compare how all these features were at the beginning and how they've been transformed through various ways up to, in order to prepare for them before training this data. And it is important to do this process of pre-processing and feature selection. Okay, so now this is the third step, and this is the step we're interested in, where the different classifiers that we learned, how are they actually implemented. So we got the data, then we tried to clean it, we pre-processed it, transformed it, and then now we're going to test the classifiers. So having the data pre-processed, we can now provide the data to different classifiers and see which one performs best by creating the model of classification for this data. We will use cross-validation, which is a model validation technique to evaluate how well a model will generalize an independent data set. Okay, so this is just, again, I think we had talked about cross-validation, but high level, what is cross-validation? It is a model validation technique. So it is a technique for validating the model and seeing, okay, how well does this model perform when given a new data point. So Python has the cross-val score class, and then also it has a class for model selection from sklearn, and we're going to be using those libraries to perform the cross-validation. Okay, so we can see that we're going to try different models, and then we assess their performance, and we're like, okay, let's try a logistic regression. Remember, we are doing a classification. We want to see, did this person survive or did they not survive? So we're going to try a classification. We're going to try a k-nearest neighbors. We're going to try an SVM. We're going to try a naive Bayes, and then they're also going to try a random forest and see, okay, using cross-validation, which I've not really properly explained, how best, which one is the model that performs the best, and that is the model we are going to use eventually. All right, so this is the code for actually doing a logistic regression. So these libraries are already existing. So we can see sklearn has a library called linear model, where you can go and import a logistic regression. And then This logistic regression can be given, it's a classifier. You see, it was given in variable name classifier, which is of the logistic regression class, and then these are the different properties. If you can go to the docs of logistic regression, it can give you the different things you can tweak, like the random state, the penalties, the attributes that you can tweak according to what you want and what they mean. Okay. So applying k-fold cross-validation. So I would advise to read a bit more about cross-validation, but at the high level, it is just a validation technique, trying to see how does the model score. So that is why you see the imported cross-validation right here, and then try to determine the accuracy of this cross-validator. Remember, this is the classifier. This is a classifier right here, using this function cross-validate, and then they say, okay, cross-validation score, this is the classifier, a logistic regression, based on these inputs and these outputs, the cross-validation of 10 folds, by 10-fold, print the accuracy. So this is where you say accuracies dot mean, and then accuracies standard deviation. Okay, so they're going to repeat this process for all the models. So the interesting part is right here. Get the model, but we haven't trained and tested yet. We're just creating the models right here. Okay. All right. So same for k-nearest neighbors. We just get the classifier, and then say, okay, what is the accuracy of this classifier when given this input and the training set X and the labels of the training set Y. Okay, then you get that. Same thing for SVC, the support vector machine. So what is the accuracy of an SVC when given the inputs of the inputs, the features which are in our data frame X, and then the labels Y. So you do the same process for SVM, you do the same process for naive Bayes, and then you do the same process for a random forest, which is also a classification, random classification model to train. Okay, and then you see the accuracies here. So you can see the different accuracies, and I think the one that performs the best is k-nearest neighbors with a random forest. So as we can see from the 5 classifiers tested in this tutorial, a random forest got the best results. So after changing the test set, by performing the same transformations down on the training set, we can then use the random forest model created and do the predictions. The submissions of these predictions were 0.779 on Kaggle. Hope this tutorial was useful in some way. For detailed tutorial on the Titanic challenge, I recommend this tutorial. All right. So this one did not really break down the process of, now this is training, and then break down the training data, and then also show you the breakdown of the testing data. Okay, let me see if that's useful. Ooh. Okay, so this is a much more elaborate tutorial, but this is just processing. I'm just trying to look for if they okay, yeah. So this is the process when you reach the model part, the modeling part. You break down the combined set into a trained set and then a test set. Then you use the test set to build the predictive model, then evaluate the model using the trained set. The previous tutorial didn't really capture that process very well. Then you test the model using the test set to generate the output file for submission. Keep in mind, we'll have to reiterate 2 and 3 until an acceptable evaluation score is achieved. So you can see that there are several models that have been imported. Okay, yeah. So this is the feature selection.